Okay, so I guess it's time to get started. So this is to talk about .NET Aspire. So if that's not what you're expecting, either you are in the wrong room or I am, but I think I'm in the right one. I hope so, at least. So I hope you're all having a good conference. My name is Chris Klug. I work as a software developer / solution architect / I'm a consultant, right? So I do anything I get paid to do within the tech area, basically. But I combine that with public speaking and training as well, because I do really enjoy going to conferences, and I do like the conversations that can be had with other developers about different things. And whenever I find something that I find interesting, I try to work with it and then write the talk about the things that I've learned and try to share my passion for whatever it is. It's been lots of different things over the years. It's been front-end, back-end, Silverlight. Any Silverlight people in here? Oh, there's one smart fellow down here. But yeah, now it's mostly back-end stuff today, so .NET Aspire kind of fit into that. So I kind of guess the first question is, what is .NET Aspire? And by now, most people have heard about .NET Aspire. It's been around for almost a year now, but I also see a very small adoption, to be perfectly honest, unfortunately. So because of that, let's start out with what is .NET Aspire. And if you ask that question, you go to GitHub and ask it, they will tell you that it's .NET Aspire is an opinionated cloud-ready stack for building observable, production-ready distributed applications. .NET Aspire is delivered through a collection of NuGet packages that handle specific cloud-native concerns. That tells you nothing. It is very well written, and it's written by some marketing person at Microsoft, probably. But it doesn't tell me what it is and why we need it. So let's back up a little bit. I've been doing web development since, honestly, 1996, I think, was the first website I ever sold, and then done it professionally since 2000, basically. So I've been doing it for 20 plus years, and when I started developing, our applications looked like this. It was a client, you went through the internet, you reached the web server, and the thing on the web server talked to a database, potentially. That was kind of what we had, right? And then all of a sudden, or not all of a sudden, but then we kind of went into, oh, it needs to be N-tier applications. It needs to be talking to a web front end that talks to an application server that then talks to a database, because deploying everything on one machine is just way too complicated. And back in the day, we deployed by basically doing FTP to the server. But anyhow, we went there, and then that kind of went into, we need more services. We did a little bit of service-oriented architecture, and then the last few years, it kind of exploded into this being your default diagram for your applications. We need at least 15 services and 6 databases to do like a time reporting Excel spreadsheet, basically. And because of that, and because we are developers, I don't know, hype-driven development is a thing, right? So when everybody says that this is cool, we all need to build this, and to solve that, we have Aspire. Because running applications like that with multiple services, multiple databases, multiple other things we need, like Redis caching and doc databases, and everything that you can think of that we need to run our applications has become really complicated, and it's hard to run our systems like that locally. And Aspire's idea is that it will offer us 3 different pillars to make this a lot easier. Now, there is a 4th pillar that I've decided to remove, because it says deployment, because it does help you to deploy, but my personal opinion is I won't touch the deployment story whatsoever, because it feels like right-click deployment, but from the console line. We can get back to that later on. Some people love it. I don't, but we'll have a look at that later on. But the most important part for me is the dev experience. And the thing that Aspire helps us with there is orchestration. We have Aspire components, and we have Aspire tooling. So the most obvious thing for Aspire is the orchestration part. So the orchestration part is that with that diagram we have with multiple services and multiple databases and caching layers and things like that, it's hard to define that. We end up doing like Docker Compose and a bunch of things like that to get it run. In Aspire, we've basically defined the structure of our solution using C#. And then we let Aspire run everything for us. So say, for example, we have this solution here. I'm building a React front end with a web API behind it in the database, which is probably the most common thing that most of us build on a daily basis, I think. Might be for more services, but that's kind of what we build. So what we do is we get this thing called Aspire App Host, which is just a C# project. So it's just another project in your solution. And when you run this application in Visual Studio or Visual Studio Code, you press F5, you run the Aspire App Host. The App Host is then responsible for spinning up your database, your web API, your React front end, making sure that they can talk to each other, making sure that everything fits in nicely in one thing, and it gives you debugging into all of your services and tracing and telemetry and everything so you can see what's happening. And all of this stuff here, which is normally like a bunch of config and environment variables and Docker Compose files and everything, becomes this. So inside our Aspire App Host, we get this C# file called program.cs. That's all we have in there in most cases. And all it does, instead of doing like web application.createBuilder or create default or whatever, we do distributed application.createBuilder. And then from the distributed application builder, we can go and say, hey, I want to add a project. And then you point it towards your, in this case, the project. Oh, look at that. I have arrows. Sorry. You have that thing. And then you add a project to it. And then you point towards, in this case, projects.myAPI. And projects.myAPI is a type that represents your project. Now, there's no type in .NET that represents your project whatsoever. But with Aspire, there's code generators behind the scene that basically says, oh, in your solution, there are other projects. So for each project, I'm going to add like a source code generated piece of thing that you can use as a type. So that we can then tell C# that, or in C# tell Aspire that I want to add a project. I want to use the myAPI project that's in this solution, and I want to call it API. And then the next line, I need a Redis cache. So I just go and say, builder, add Redis. Add Redis will then basically make sure that when you run the Aspire host, there is a Docker container with Redis that spins up on your machine and runs together with your application. And finally, I add my web project in this case, and I say I name it web. And then I say, hey, I have two references. I want to reference the cache project or resource, and I want to reference the API resource. Now, the cool thing about having these references that we've got down here is that they allow Aspire to inject information into the web application when it runs, and basically makes it possible for the web to automatically figure out what's the connection string and the credentials to talk to Redis, and what's the connection string to the API, because the API is going to spin up on some port on your machine, and Redis is going to be somewhere else, and things like that. So what happens when you run it is that Aspire creates this hosting project for you and spins up your processes for you. And if the web has a reference to the cache supports connection strings because the cache is a Redis cache, so Redis has connection strings. What Aspire allows us to do, or basically does for us, is that it goes to the cache and say, hey, can you give me a connection string to you? And it says, hey, here's the connection string. And then that gets injected into web so that web can go and talk to the Redis cache. And for the API doesn't have a connection string, but it has a URL, right? So to be able to talk to the API, it's going to be like https://localhost port something. But ports change and things, right? So what happens here is we get a service binding. Aspire goes to API and says, hey, can you give me your endpoint, your HTTP or HTTPS endpoint that you have? And then I'll take that and I'll inject it into web, and web can then find API based on the name API instead of localhost port something something, which is really cool. It makes life easier. And I haven't used Redis a lot myself, but I use SQL Server a lot with this. So SQL Server spins up a SQL Server container on your machine for you automatically. And when it does that, it also auto-generates like a many-character-long random password for the SA account and all of that, and you don't have to care. You don't have to make up a one. You don't have to check something in. You don't have to have some weird stuff. It just gets injected by Aspire automatically, which is sweet. Out of the box, it kind of supports add project, add container, add Docker file, and add executable. So add project, obviously, you have another project in your solution. You can reference that. Add container is, hey, I have a Docker image. Can you please run that for me? Add Docker file is, hey, I have a folder with a Docker file inside of it. Please take that Docker file, generate an image for me, and run that image for me automatically. And add executable is probably the the weirdest one here, but makes a lot of sense. It allows you to basically point at an executable on your system and say, when I start Aspire, run this executable. And then, just as with container, Docker, and file versions, you can say, oh, the thing that you're spinning up exposes port X, Y, and Z. And then, basically, you got the whole endpoint thing being injected properly as such as well. And there are more. There are NuGet packages where you can add more things. There, for example, I know that there is an add npm project. So if you run JavaScript applications, you can actually use Aspire and just point to the folder where you have your React project, for example, and it will start up and run npm and spin up your application as part of Aspire. That's kind of neat. Code looks like this. If you want to use a container, you just go builder.add-container. My container is the name. My-image is the image name of the container. You give it. So with containers, it's a bit complicated because containers don't have a way to say what ports they really expose properly. So you have to go in and say, oh, I want you to run that container, and that container, I want you to create an endpoint for it. So basically, I want to call the endpoint my endpoint. It should target port 80 inside of my container. It should have port 8080 local on my machine. If you don't want to have port 8080 hard-coded, it will just generate a random port for you and put it on that, and then you can inject that in somewhere else. And then you tell it whether or not it's HTTP or HTTPS. And then when you want to use it, you just go and say, hey, I want to reference this container thing. The endpoint name is my endpoint, and then service location just marries it all up, and it just starts working, which is really cool. Now, when I say service location just marries all up, and it's really cool, what I also like about this is that there is no magic going on in here. There's no secret sauce that Microsoft has poured on top of it that you don't understand. Because I know that Microsoft used to love, especially in Visual Studio, they would have like things that just magically worked and nobody really knew how it worked. Service location is the only complicated thing in here, and you go, if I want to use this endpoint in my application, how does the application know to use that endpoint if I want to do like an HTTP call? So if I have an HTTP client and I want to call my endpoint here, how do I call that? Well, you just write HTTP client, and the URL to use is my HTTPS:// my endpoint, and then the path. And then the my endpoint stuff is just magically turned into localhost, port, whatever. And the way that that works is that it actually is just an environment variable. So this whole service location that is so cool within Aspire is actually just based on a NuGet package that does service location for different services in C#. So HTTP client, gRPC client, HTTP forwarder, a bunch of different packages can tie into this service location system. And instead of when you do HTTPS:// my container, instead of doing a DNS resolution through the DNS, there's a little thing that plugs in between and says, before you go to DNS, let me just look at my environment variables to see if I have an environment variable with this format here, which is like services __ name of container __ my endpoint in this case, and 0 if there's more than one. There can be more namespace or more environment variables. But it's all just environment variables that you can use. And you can then keep using my container in production as well, because in production, you just make sure that either you inject these environment variables in your production system, or you create a DNS server in your production environment that has those names in there, and it just keeps on working on a production system as well as on your local machine. Yeah, kind of the same thing. Just so you can pull out your endpoint and inject the endpoint separately if you want to. And as I said, in this case, it becomes an environment variable, very simple like that. And in your code, you just do that. You just tell it that, hey, the client base address in this case is going to be HTTPS:/ my container, and you just leave it at that, and Aspire solves everything else. Now, there is a lot more to it, because there is actually reverse proxies and a bunch of port mapping and blah, blah, blah going on under the hood. Let's ignore that and just say that it works. Makes it a lot easier. Also, when you do point at a project, so you go add project and you point at one of your projects, it knows about C# projects. So it knows about launch settings.json, right? So under your properties folder in your solution, you have launch settings.json. That has a bunch of JSON in there that tells you how to launch your application. And it has a default one when you press F5 and you run the application. If you don't want to use the default launch profile, you can have a specific launch profile for your application, so you can move the port it's being used at and things like that, and it all just ties into that launch profile settings.json or launch settings.json that Visual Studio and Code also uses behind the scenes. The other leg that we've got with Aspire is components. So Aspire components are NuGet packages on steroids, kind of. What they do is they give you the same things that you're used to in a lot of cases, but with sensible defaults for a cloud environment. So we do know that this application is going to run in some form of cloud-enabled environment, probably, like Azure or AWS or your own local cloud. And because of that, because it's cloud, you probably want to have things like retry logic, right? You want to make sure that if the connection is down for a little while, it retries everything. You want to make sure that you get telemetry in there properly, so you get open telemetry support with endpoints and things like that. You get health checks and all of those sensible things that you'd expect from your system. But if you just go and add it with the default NuGet package, you have to figure out what sensible defaults are. Aspire components give you sensible defaults to begin with. And there are lots of those components. This is an old list, unfortunately. It grows basically every day. It's all open source. So here you can see a bunch of the components that they support, or systems that they, or services they support in component style. So Kafka, a bunch of Azure services, Redis, SQL Server. And whenever you add these, you can go and add the regular SDK package from NuGet as you would normally. But honestly, one does not simply add a NuGet package. Because when you do that, you don't get sensible defaults. You get a default installation of something, and then you have to figure out that for HTTP client, I should have retry policies. And for entity framework with SQL Server, I should have retry policies, and I should use connection pooling, and I should use a bunch of different things that they will give you out of the box, because these are kind of what we'd expect you to configure for a cloud environment. So it does give you automatic configuration and sensible defaults, but mostly the automatic configuration gives you logging. So it ties into OpenTelemetry logging automatically. You just add the NuGet package, and it goes into logging properly with OpenTelemetry support. It has tracing support, so even if you have a distributed application with many services, it plugs into OpenTelemetry's distributed tracing model with tracing going across all of your services. That's just in there by default. You get metrics, so if you go ahead and add SQL stuff there, for example, all of your SQL metrics go into your OpenTelemetry things and things like that as well. So all of that is just out of the box. And then you get to look at all of that stuff, because OpenTelemetry doesn't show you anything, right? OpenTelemetry is just a transport to be able to show your OpenTelemetry information, your observability stuff, to something else. So Aspire comes with this Aspire dashboard, which is an OpenTelemetry dashboard that ties into OpenTelemetry data coming out of your application, so that when you run it locally on your machine, you can see what resources you have configured, the state of the resources. You can see logging from every single one of the things that you're running, both on a console level, but also as a structured logging system. And you can see tracing, so you can trace through your distributed application to see all of your calls and how long each part of that call took and all of that, but just works out of the box. You get metrics, so it plugs into your standard metrics, as well as if you have custom metrics, they just show up here. So as long as you do everything you would normally do with OpenTelemetry, or you're getting started with OpenTelemetry, all of it will tie into this dashboard and allow you to monitor your system locally, as well as honestly in the cloud as well, because this dashboard is available to deployed separately. The only thing to remember that this dashboard doesn't actually store any data. It is just a snapshot of what you're running at the moment. So when you run it locally on your machine, your OpenTelemetry data is being shoved from your application to the dashboard. The dashboard shows the data and then throws it out. So it doesn't store it anywhere. But if you do want to store it, it's OpenTelemetry, right? OpenTelemetry is a format or a way to do your transport of your observability data, and it works very well together with, for example, Azure Monitor. And if you do want to use Azure Monitor and you actually want to put your OpenTelemetry stuff into Azure and have a look at it, there's this piece of code in the starter package that you basically just uncomment the add Azure Monitor. And once you've done that, your data goes straight into Azure Monitor and Azure App Insights, as long as you remember to inject an environment variable into your project. So you do also need the application insights connection string environment variable to be able to get this to work with Azure. And finally, you also get health checks. So health checks is built on the standard ASP.NET Core health check system that they have, but it's kind of cool because when you plug your other components into, like your SQL component or your Redis component and all of that, it plugs into the health checks endpoints as well and gives you endpoints to verify that everything in your system is online, and you can do health checks on those specific systems as well. So you can make sure that your SQL Server is online and your Redis is online and all of that stuff. And as I mentioned, the resiliency stuff, they do try to configure stuff with resiliency in mind, because in the cloud, stuff come and go a little bit as it feels like. There's a bit of code in your ASP.NET or your Aspire project that has these two things. So when you create the client, the HTTP client, it configures the HTTP client defaults by using standard resiliency handler. What that actually means is black magic. Actually, you can find it on GitHub. It's not very well documented, though. But if you go to GitHub, that extension method basically just adds retry policies that are useful for HTTP client. And you also tell the HTTP client to use that service discovery stuff with environment variables. So this is quite an important thing. You'll see that when we look at the code later on, is that none of this stuff is hard-coded to Aspire. There's a bunch of stuff in Aspire that's part of the NuGet package, but things like configuring your system is actually a separate project in your solution. So when you start an Aspire project, you get 2 projects extra. You get the app host that I've been talking about, but you also get a separate CS proj, or a C# project, that has the default configuration so you can go in and modify it. So if you want to have other settings for open telemetry, or if you want to do other things with HTTP client and things like that, it's all there for you to modify in a very easy way with a separate project, which I really like compared to everything in a NuGet package. Aspire components are basically just NuGet packages, as I mentioned. They are deployed or published under the Aspire dot prefix. So you can go in, and anything that starts with Aspire dot is meant to be used as a NuGet package in an Aspire project. But you can use them in any project if you want to, but you won't get the full usefulness that you would out of Aspire. And apparently I copied the wrong project here, or the wrong PowerPoint, because you don't need pre-release anymore. Sorry about that. Aspire stuff is all public now, or in all GA, so you just do .NET add package, in this case the SQL Server client. So you add that to your project. Then you go and you add SQL Server client, for example, in your application. And instead of going builder.services. All of your Aspire components actually tie in and have extension methods on builder, not the services collection. So you do builder.add SQL Server client, and you give it the name of your connection string, which in Aspire world is going to be the name of your SQL Server resource that you have defined in app host. And once you've done that, you just got dependency injection. So you just ask for a SQL connection, and it will inject one that has retry policies and has the connection string set up and everything, so you can start working with it. And as I said, it all comes with health checks, metrics, tracing, connection pooling, automatic retries, all the things that you want to have when you're working with SQL client. If you, for some reason, don't like OpenTelemetry stuff or health checks, you can go in and turn it off. So none of this is mandatory. Everything is optional, but it's basically an opt-out instead of an opt-in when it comes to all of the observability stuff, which I think is a good idea. And if you, for some reason, feel like poking your eyes out and do everything the complicated way, you can define all of your configuration in JSON instead. You can, but you... Honestly, that, compared to that, I'm just going to leave that out there. I just can't. At least it's not YAML. It's one step above YAML, but it's still that. So use C#. I prefer that. If you want to do more than one thing, so for example, SQL Server client, you might want to have more than one SQL connection. You want to have to 2 different databases, for example. Then you use keyed services. So we have keyed services in DI. So all you do is you say, hi, I have a keyed service. And then you basically tell it the name and things, the name and the connection string, and then you go from keyed services, and then you get one that is specific to that key instead, which allows you to have more than one thing installed. But there's also, if you move, so all of that SQL client stuff will be in your actual application, your API or your web project or your service project or whatever. If we move back up to the host, like the Aspire host, you have components for the host level as well. So the components that go into the host are more sort of like overarching things, like in this case, add SQL Server. So you go and say, I want to have a SQL Server, I want to call it SQL, I want to have a database called my database, or MyDB, and I want my app to be able to talk to the database called MyDB. If you do this and you run the project, it will spin up SQL Server on your local host in a Docker container. Now, a little part missing here is that you probably never want to do this, because it's a Docker container that comes and goes, right? So if you start your application, it will spin up a container, it will use the database, and when you stop it, it will kill the container, and what happens to your data? Well, your data went, poof, it's gone. You can map a volume or a bind mount into this and get persistence for your data, which I would generally recommend when it comes to data, because we often want to use a database to actually store data, I guess. And then once you've done this, and it spins up the container for you, when we reference MyDB, that will automatically inject a SQL connection string into my application. So inside of the application or the service, I just go add SQL Server client and the name of the database, and it just works. I never have to play around with passwords or anything like that. Or the whole actually, just being able to create and write a connection string. I've been doing this for 20 plus years. I have never been able to type a connection string properly from scratch. Connectionstrings.com is probably my most used website ever when it comes to development. This takes this out of the way. I don't have to see connection strings at any point. And once again, there is none of the magic that you'd expect behind this at all. All it happens is that your application gets a connection string underscore MyDB environment variable, which ties into the configuration system of ASP.NET, which means that you get a connection strings : MyDB configuration variable. That's all it really does. The last part I'm going to talk about is tooling. Well, tooling is interesting. It gives you a few plug-in things to Visual Studio. Once again, I did unfortunately copy the wrong slide deck for this presentation, so I haven't updated these slides, but I can tell you that you need .NET 8+. That's about it. You need the .NET Aspire workload. I saw on Twitter today that it's apparently going to go away as a workload and become something else. I have no idea how that works. But right now, it's an extra workload. If you want to use the container stuff, you want to use Docker Desktop. If you don't want to use Docker Desktop and you want to have a free version, you can use Podman. So Podman is just a matter of installing Podman, setting an environment variable on your machine, and Aspire will use Podman instead of Docker Desktop. And for the IDE, you can choose Visual Studio 2022, doesn't need to be preview anymore, or Visual Studio Code, or Rider, or anyone else that I've implemented. But I think those three are the ones that I know work well with Aspire. And once you've done that, when you go to Visual Studio, you do new project, you get 4 new templates. You get Aspire starter application, which is one I'm going to show you. You get an Aspire application, which is empty. It just has the app host and a service defaults project, and then you can start adding your own stuff. You get an app host and a service default project. I don't know why you would use those without the other stuff, but it's there. And if you have an existing project, you can just right-click it and say, add Aspire orchestration support, and it adds those projects to you and tie everything in, and all of a sudden you've got Aspire in your application. So the solution that you get from this starter application is basically something that looks like this, which is maybe a little small for the people in the back, but hopefully you can see a little bit of it. What you get is the Aspire app host, which is the project that you run to start your application. You get the service defaults, which is a shared project that all other services depend on. It has some extension methods that are being called in program.cs to sort of Aspirify your application. And finally, you get 2 projects. You get an API service and a Blazor front-end application or a web application that you can have a look at how it works. So let's have a look at demo and see how it works. So I'm going to pull up. I'm not going to go and show you my email. What I wanted to do was Visual Studio 2022. It's not a preview version. It does work in the preview as well. I do create new project. We go Aspire starter app. Nope. We go Aspire starter app, and we click next, not back. We give it a name, so I'm going to call this thing Aspire demo, and I'm going to put this somewhere else, because that location is not great. So I'm going to put it in NDC Porto. Next. It asks for .NET version. I'm going to use .NET 8, which is fine. Configure for HTTPS. That's fine as well. I'm not going to use Redis, and I don't need any tests in here, so we'll go create. And that is really small. Give me a second. Let's try this. Let's go and go presentation mode. And we do open project or solution. Actually, it was there, wasn't it? And oh, that was another one. Open. Let's just go and open it in this, so I think the people in the back can see it as well. So we'll do Aspire demo solution. That's a bit more. It's not fantastic, but it's at least a little bit bigger. Sorry about that. So what we get is exactly what I showed you. You get the app host, you get the service defaults, you get a web project, and you get the API service. So let's go ahead and start looking at the API service, because that's kind of the simplest thing in here. It is a very simple API. It has a minimal web API, or minimal API in here. Nothing complicated in here whatsoever, but there are two things in here that is not in your average project. It is the add service defaults, which is an Aspire extension method, and map default endpoints, which is also an Aspire extension method. So if we go into the add service defaults one, you can see here, if we look at where we are, we end up in the service defaults project. So all of our services should reference the service defaults project and call these two extension methods, because it means that they will all have the same configuration. And what you do in here, or what they do in here in add service defaults, is it configures OpenTelemetry. It's another extension method that we can jump to, and you can see here is all of your configuration for OpenTelemetry. So it goes add OpenTelemetry. If you want to make that differently, you can do that. It does add metrics, so it adds the default metrics in here. It does tracing stuff, so it basically says, hey, I want to do tracing on HTTP, but if you do want to use the gRPC instead, you just uncomment this line of code here, you add one more NuGet package, and all of a sudden all of your gRPC methods or calls are now being instrumented with OpenTelemetry as well. And then finally, it goes add OpenTelemetry exporters, which is another extension method, and in here it basically says, hey, if it finds this thing here, use OTLP exporter. Otherwise, don't do anything. But if you do want to use Azure Monitor, you just uncomment these lines of code here. It looks for the application insights connection string. If it finds one of those, it adds OpenTelemetry, exporting to Azure Monitor, and all of a sudden, everything that's being done with your application will be in your application or your Azure Monitor, so you can see all of your traces and your logging and everything in one single place. And if you don't want to use Azure Monitor, you've got a bunch of other scenarios. You can just plug them in here. If you want to use Honeycomb or Jaeger or whatever, it plugs in here. It's nice. So that's kind of it. And it's all in here, and you can have a look at it. And if you want to reconfigure it because you know better, then go ahead. It's all here. And the second part I mentioned was the map default endpoints down here, which it does right before run. Another extension method, and all it really does, it goes in and says, hey, if you're in development, add health checks so we can see them. Now, the reason that it does is development before it adds the health checks is because there are some security concerns about health checks. They are an attack vector to do DDoS attacks on your system, so you don't want to run them in public as an unsecured endpoint, because that could cause you some really interesting scenarios with your system not being available, which apparently is a bad thing. The other part of the system is the web application. So once again, we go and look at the web. There's nothing more complicated in here either. It's like we've got the add service defaults at the top. We have the map default endpoints at the bottom, just as it should be for an Aspire project. And then it sets up a couple of things here, like an HTTP client. And if we look at the HTTP client, you can see here that it says client base address, new. And this syntax is kind of cool. You cannot use that syntax all over the place, but for the service discovery stuff, if you do HTTPS plus HTTP, you're basically saying to the discovery system that if you can find an HTTPS endpoint, use that. But if you don't find an HTTPS one, you can fall back and use HTTP. I'm OK with that as well. So you have this extra syntax of going like fallback. So if you want to run HTTP only locally, for example, then don't give it an HTTPS endpoint, and it will still work for HTTPS in the production, for example. So that's kind of it. It's two very, very simple applications. And the cool thing is if I press F5, and then wait a little while, it pops up in, as you can see, it starts the Aspire app host in this case. It runs through a couple of things. It spins up the application for us. And here are the resources we requested. So we got the API service, we got the web front end, there are 2 project types, and we get the endpoints for them. So if we go and have a look at the web project, for example, it loads up a web application on port 7025. We can go to the weather endpoint. The weather endpoint then goes and uses the HTTP client to talk to the other API using HTTPS plus HTTP://API service. And it runs it for us, which is kind of sweet. And if anything happens, well, actually, one thing we can have a look at is how does the injection of service location work? And it's actually quite simple. We have a reference. I'm going to show you that later on, but it references the web front end references the API service. And what happens when you do that is we go into the details here. And honestly, this view here is worth installing Aspire just for that for me, because it basically shows me every environment variable being set for that process that I'm working on, which is really neat. And one thing I can find down here is that it says, hey, services __ API service __ HTTP __ 0 goes to HTTP. And the other thing is API service HTTPS goes to HTTPS, and it has the ports and everything mapped in here. And when you do the / API service, the service location stuff looks at these environment variables and then converts API service to localhost port, whatever we want. Now the cool thing in here is we've got console viewing, so we can look at the console logs for our individual projects, which I really like, because I know that when you do Docker Compose and things, they try to render it in sort of like one view, but it comes sort of like intermingled and everything. This gets sorted out so you can filter it based on one of the services at a time. If you don't like the regular console output, you prefer structured logging, you get structured logging as well with filtering turned on, so we can go in here and see what the logging is for a specific service. We get traces, so each one of these logs, actually that doesn't have it, but if we go to web front, then each one of the log entries is connected to a trace. If we click on the trace ID, we get the trace for that specific request. So we can see here that we requested the weather endpoint, then there's the browser link thing, and then the web front end did a get call to the weather forecast. We can see the timings in here, and so on. So we got all of the traces for everything that goes through our system available to us. And finally, we got metrics for each of these resources. So if we look at the web front end, for example, we can then go in and see how many active requests do we have, what's the average duration, and things like that. And these things are ridiculously easy to plug into. So if you want to do your own metrics to keep track of how many people log into your system or how many orders you're doing, we're talking about 7 lines of code to be able to plug into this thing and start adding things to these graphs, which is quite neat. So now that we've seen that it works, let's go back and have a look at the app host. So this is the magic sauce, which is not very magic, and it's also not a lot of code in here. It basically just goes distributed application.createBuilder. It says add project, and I want to reference the API service project, and I want to call it API service. I want to add the web project, call it web front end, and then I add the reference to the API service. Actually, I don't. Microsoft added that for us so that they can communicate. And then finally, the with external HTTP endpoints. If you were to use the deployment scenario inside of Aspire for some reason, if you don't add that, you don't actually get a public IPM endpoint for your thing. It basically creates it as an Azure container app, and it doesn't get an ingress, so you can't actually reach it. So anything that you need to be able to reach from the internet needs to call with external HTTP endpoints to be able to make it externally available. Locally, doesn't do anything whatsoever. All of your services will always be available locally. So let's write something that makes this a little bit more useful. So I kind of looked at this and went, OK, that's a cool demo. What if we put a database in there? How hard is it to get Entity Framework to do this for us, and how does it work? So what I'm going to do is I'm going to turn this into a little Entity Framework database thingy that does it for us, so we can see how we do database calls and SQL Server and things like that. And the first thing I need to do in my API service is that I'm going to go and say add, and here you can see we get a new thing in here that says Aspire component, or sorry, Aspire package. If we choose that, it opens the not so fantastic NuGet window, which is really slow. But it adds like owner Aspire tags component, and then you can go in and what we want is Aspire Microsoft Entity Framework Core SQL Server. That is exactly the package that I want. So I'm going to install that. So now that I have that, I'm going to go to my API service, and I'm going to go and say add folder. I'm going to call it data. I'm going to add a new class in here. I'm going to call it weather, if I could spell, weather context. And I'm going to go ahead and, because I can't type, I'm going to replace it with that. So it's just a very simple DB context from Entity Framework Core, nothing complicated. And inside here, I'm going to add one little mapping. So I'm going to map the entity called weather forecast. Weather forecast, the entity as such, is the same thing that's being defined here in the program CS and being used by the API, so the current API. So I'm just going to reuse that thing, but I'm mapping it towards the database instead and saying, hey, it's going to be a table called weather forecasts. Now, I also need a migration to add the actual database. So let's go ahead and add an initial migration. Let's also replace that with this piece of code here. So initial migration is just a SQL Server or Entity Framework migration. It creates a table called weather forecast. It creates an ID, a date, a temperature, and a summary columns. And then finally, please do not do this. But for the demo, I'm going to add some stuff into the database as well. If you want to seed your database with data, don't do it in your migrations. Do it somewhere else. It makes it better. And also, if you want to seed your database, using a random thing to just throw in random weather forecasts might not be the best solution. But for my demo, this is going to work just as well as the demo that Microsoft wrote for it, because they also just make up weather forecasts. Now, we need a database, right? And I'm going to ask Aspire to host my database. So in my app host, I'm going to go and say add Aspire package. This time it goes owner Aspire tags hosting, so we get a bunch of other packages for the hosting side of things. And what I'm going to use in here is I am going to use SQL Server. I shouldn't replace all of it. It should be there. SQL Server, that's the one. Just add that. Accept. And then inside my program CS, somewhere around, not that program CS, sorry, this one here in app host, I'm going to go and add a database. So I'm going to go say this, add SQL Server. I'm going to give it a name called SQL Server, not going to be used anywhere, except for in the dashboard, it's going to say SQL Server. Then I do a with bind mount to tell it that, hey, I want to bind this path on my local machine to this path inside of my container, which means that all of the MDF and LDF files for SQL Server gets added to that directory, which means that they end up on c:temp SQL data on my local machine. So when I restart the application, ta-da, data is still there, which is quite nice. And then I'm going to say, once I have the SQL Server, I want to add a database called WeatherDB. Now, this thing here I had to put in here because it is so stupid. Or actually, there are two things in here. The first one is this. You do not need to give the SQL Server a password at all. You can let it auto-generate the password for you, but because I am weird and have OCD, I wanted to give it my own password so that I can then use SQL Server Management Studio to log into it easily and things like that. You cannot just pass in password p at ssw0rd ! As a string. That would be way too simple for a password, right? So to be able to pass in a string to be the password, you need to go builder.create, create resource builder, pass in a parameter resource called password, and give it a function, or sorry, a func that returns the password that you want to use. Why? No idea. It's just dumb, but that's the way the syntax looks. And the reason I brought it up is because I tried to do it, and I couldn't find how to do it, and I couldn't find online anywhere any samples of doing it. So once I finally figured it out, after like 40 minutes of Googling and swearing and screaming at my computer, I thought I'd leave that in there if you ever wanted to do it. And finally, because I already have SQL Server on my local machine, I am changing the port from 1433 to 14,330. Because I don't want it to collide with my existing 1433 on my local host. So that's about it. Once I have that in place, we can go ahead to go to our API service. and say dot with reference DB. Just say I want to be able to talk to that database. That's all I need to do. Go back to my program CS in my API service, and then up here, let's do it somewhere around there. We can do this. We do builder.add SQL Server DB context. Once again, this is the Aspire add SQL Server DB context. The one that comes with Entity Framework actually goes builder.services.add DB context. So this is a slightly different one, and also it doesn't take the connection string here. It takes the name of a connection string. And the name of the connection string that you pass in here is going to be the name of your database that you used when you created the resource, the database resource. So as long as that string and that string marries up, connection string is sorted. You don't have to care at all. Now, the last thing we can do is we can remove this, because I don't want to use that anymore. And I want to use something that looks like this. So I'm replacing weather forecast with just a simple implementation that takes a weather context and then gets everything that's in the database, because that's honestly not what you want to do in a real-world scenario. Once again, it's a demo. Sorry about it being very simple. But this is then going to connect to the database, get all of the weather forecasts, and return it back just like it did before. Now, we need to do one more thing. We need to go ahead and add in here, we need to add that. So that's just the run migrations when the application starts up. Please, once again, don't use this in production, which is why I've put the is development in here. I know a lot of people just do this in their code, and they're happy and it works locally. It works when you go to production as well, and then somebody says, let's scale this out to more than one instance, and then you deploy your system to more than one instance. 2 instances or more spin up at the same time. They run this code at the same time, and there's just one winner because everyone else deadlocks and dies. So run your migrations outside of your application startup, or find somewhere to, I don't know, deploy one and then deploy the rest of them at a later point or whatever. Just don't use this in production as is, because it causes problems. Now, if I go and run this, it starts up Aspire again. That's a good start. It didn't break at that point. It loads up the dashboard. It now shows me there is a SQL Server resource. It's a container. We can see what image it's running. It gets the port 1433.0 as I wanted it to. We can see the SQL Server database is up and running. And if I go to my web project, we can go to the weather endpoint. It takes a little while because it needs to run the migrations. It needs to start up SQL Server and all of that stuff. But after a little while, it shows up and it's now talking to SQL Server. Now, the cool thing with this, so far, 0. There's nothing cool about this except for the SQL, like the connection string being automatically generated. But since I'm an idiot, I had to do the whole password thing on my own, which means that I could just as well have done it completely on my own. But let's ignore that and just say the cool thing comes now, because everything is just magically connected, I can go in here and I can look at the trace that I did for my last call, and we can see that I connect to the weather front end, then it connects browser link, then I do a call to the weather forecast endpoint, and then that talks to the API service, the API service talks to the database, and the database responds within 5.56 milliseconds, so you can't even see the little sliver of time that goes in there. That just popped in because of Aspire, it plugs into OpenTelemetry. Now, a cool thing that I saw here that I didn't think about initially was I went into the logs and I went to the API service, and this looks everything looks fine. And then you scroll up and it says, hey, wait a minute, something went wrong. It goes, a transient exception occurred during execution. This is really cool because SQL Server takes about 2 to 3 seconds or something like that to start up inside of a container because it needs to run a few things. But the rest of the system goes online instantly because of Aspire. But because I am using Aspire components to add the SQL Server stuff and Entity Framework stuff, it has retry policies enabled. And because retry policies are enabled, when the database isn't up, it retries over and over again a couple of times until SQL Server comes online. And once SQL Server comes online, it goes and runs my migration and adds my seed data, and then basically responds with the request that I just did. which is why there's a long period of time when I'm waiting for the API service to come online, and that wait is basically SQL Server. And that works out of the box because we ran it. And I ran similar thing for this for a workshop I was doing, and for some reason my machine was doing something else at the same moment. And SQL Server took about 40 seconds to come online, and my machine just stood there. And I looked at the logs, and it actually failed all of the retries for SQL Server. But because I went to request API went to the database connection retried several times, then failed, returned an error back. The HTTP client that did the call had retry policies enabled as well, right? So it just retried once more, sent another request, waited for another couple of SQL Server retries, and then got the response back. So even if it failed something like 16 times before I got the response, and the response took 40-something seconds to get back, nothing failed. The system just kept on running, and even if it was slow, it did respond properly, which is quite nice. Another thing that is interesting in here, from me geeking out on Aspire as such, is that if we go into the API service and we look at the connection string down here, which is, where was it? There it is. SQL Server 127.001.14330, just what I told it, right? And user ID SA and password is my password. So that looks probably okay. Until you go to your terminal and you go docker ps and you look at SQL Server and it says port 127.001.59242, which is not the port that I was asking for at all. I was asking for 14330. And the reason for this is because of that Batman thing I showed you in the slide deck. There is stuff going on. There's actually a reverse proxy being put in place in front of every single one of your services. So if we go into the SQL Server and we look at the details for SQL Server, you will see that it has a TCP port saying that you should listen to this port, but the target port that is for your container, where the container is actually hosted, is that port there. So what happens when you do a request is you do a request to 14330, 14330 redirects or proxies to 59242, which then it gets converted into 1433 inside of your container, but honestly, who cares? It works, which is, I guess, the important part. Let's go back here. And I said there was a fourth pillar that I kind of ignored and didn't put in as one of the important pillars because, well, this is very much my personal opinion. You're allowed to have your own. It might be wrong, but let's leave you have it anyway. I dislike the deployment scenario to a certain degree. So with Aspire, you have the ability to run this command here. So you can do .NET run, you run your project, but you do a publisher manifest. And when you run that, it basically runs your application or runs your Aspire app host, and it generates a JSON manifest describing your system. So it looks like this when it comes out, a bunch of JSON. It basically says, there is one resource called SQL Server of the type SQL Server v0. There is a MyDB of type SQL Server Database v0. There is a service in here called API service. It's a project. The location of the project is this. Here are the environment variables that I set. Here are the different bindings that are being set up. And then the web front end has another set of JSON in there. And in the web front end, there's references saying, I have a reference to this thing over here, and blah, blah, blah. It basically describes your environment in JSON format, which I love. That part of the story is fantastic because not only can people go and Microsoft can go and write a thing that deploys this to Azure, AWS, who have already added a bunch of Aspire components to the marketplace or to NuGet, can go and do their own. So if you want to deploy to AWS, they can take this manifest and generate the resources needed to run your system in AWS, and Azure can go and do it in their version. And if you are somewhat handy with C#, you could go and read this and basically find a way to deploy it to your local system and your own on-prem cloud, for example. That part is sweet. The part I don't like is Azure Developer CLI. Hopefully Jason is not in the room, because Jason and I had discussions about ACD. He has a different opinion than me. ACD has some really cool features, I do admit, but they also tied into Aspire. So inside of an Aspire project, you just need to say ACD up. ACD will then go and run that Aspire manifest generation to get the JSON file. It will then take that JSON file and generate bicep files from that. Then it will take those bicep files and provision them inside of Azure. And then they will take your code and generate Docker images out of it, upload your Docker images to Azure Container Registry, and deploy your images to an Azure container environment that they have provisioned for you auto-magically, making sure that your system just runs. And it works. The fact that I don't like it is inexplicable in a lot of cases, but for me, it feels like right-click deployment. It feels like right-click publish in Visual Studio. I don't like deploying like this. I need more control, which is why I'm not 100% sure of this. There is also a way now to do synth out of ACD. There's a synth command that allows you to say, here is my Aspire project. Can you give me the bicep files that you would use? Then it outputs the bicep files, and then you can modify those to your heart's content, and then you can deploy to that. The problem is that whenever you redo the synth, you get your bicep files from scratch again, and you have to make the changes you just did to be able to do it. I'm not saying that this will not be really good in the future. For now, not overly happy as such. But the development story is so good that I don't really care if the deployment story is not there yet. I love using it. And then I guess the question is, if you're not doing a greenfield project, what if you already have a project? Is Aspire something for you? Yes, it is. You go into your project, you right-click it, you say add Aspire orchestration support. When you do that, Aspire will automatically create an app host for you, a service defaults for you. It will add your web project to the app host as a resource, and it will inject the add service defaults and the map default endpoints inside of the project file of your web project. And then after that, you can slowly start migrating your NuGet packages to be Aspire packages instead, so you get all of the benefits of Aspire. But you can definitely run this on pre-existing solutions without it actually being that hard. Next slide should have been removed. It is not preview anymore. It is GA. It's been GA. There's new stuff coming out in version 9. Version 9 is being released in a month or two, whatever, for the .NET Conf thing, which I guess is a month or two away. Other than that, I just want to thank you all for listening. Reviewing my session, no. You cannot review your session there. Sorry about that. You review your session by dropping a green note in the plastic thing out there. If you want to drop something else, please come up and tell me why you want to drop something else so I can tell you why you should drop the green one. And then you drop the green one so I can come back. OK? Thank you all for listening. See ya.